Hey there, welcome to our channel. Today we're delving into a topic that impacts us all, the presence of greenhouse gases, specifically carbon dioxide, in our atmosphere. Have you ever wondered how much carbon dioxide is swirling up there? And more importantly, how fast is that amount doubling? We'll stick around because we're about to break it down. The culprit behind carbon dioxide emissions is combustion, especially burning fossil fuels. After the industrialization period, the levels of carbon dioxide in the atmosphere skyrocketed. The major contributors: electricity and heat production, transportation, and industries, all heavily reliant on burning fossil fuels like coal, oil, and natural gas. Surprisingly, China and the United States are leading the charge in releasing the most carbon dioxide. Now, let's get into the nitty-gritty. To find out the doubling time of carbon dioxide, we need to understand the present amount in the atmosphere. One way to estimate this is by considering the troposphere, the layer of our atmosphere closest to Earth's surface. The percentage of carbon dioxide in the atmosphere is estimated at around 0.04% by volume, and Earth's radius, say Re, is 6371 kilometers. The combined radius of the troposphere, let's say RT, will be equal to 6371 plus 12, is equal to 6383 kilometers. So the volume of the Earth will be V, which is similar to 4 over 3 multiplied by pi multiplied by Re to power 3. So we will be equal to 1.083 multiplied by 10 raised to the power 12 kilometers cube, and the combined volume of Earth and troposphere will be 1.089 multiplied by 10 raised to the power 12 kilometers cube, and the difference will be 6.133 multiplied by 10 raised to the power 9 kilometers cube. When we convert the value Vt into a meter cube, the value will be 6.133 multiplied by 10 raised to power an 18 meter cube. As we already know, the percentage volume of carbon dioxide in the atmosphere is 0.04%, and the volume of the troposphere is 6.23 multiplied by 10, which is enough to power an 18 meter cube. The volume of carbon dioxide in the atmosphere will be 6.133 multiplied by 18 multiplied by 0.04 divided by 100. We find that the present amount of carbon dioxide is a whopping 2.453 multiplied by 10 raised to power 15 cubic meters. Now, let's talk about the annual energy consumption, a staggering 5 multiplied by 10 raised to the power 20 joules. To determine the volume of carbon dioxide released per year, we use the enthalpy change of 394 kilojoules per mole, where the negative sign represents the heat released so that the reaction is exothermic. 1 mole of carbon dioxide corresponds to 22.4 liters or 22.4 multiplied by 10 raised to the power minus 3 meter cube at standard temperature and pressure STP, so the carbon dioxide released per year will be equal to the volume of carbon dioxide at STP divided by energy released per mole of combustion multiply energy consumption per year, which will be equal to 22.4 multiplied by 10 raised to the power minus 3 divided by 3.94 multiplied by 10 raised to the power 5 multiplied by 5 multiplied by 10 raised to power 20, which will be equal to 2.843 multiplied by 10 raised to the power 3 meter cube of carbon dioxide released per year. If the emission rate remains constant, will be equal to the volume of carbon dioxide in the atmosphere divided by the volume of carbon dioxide released per year, which will be equal to 2.4553 multiplied by 10 raised to power 15 meters cube divided by 2.843 multiplied by 10 raised to power 13 meter cube, which will be equal to 86 years. So what's the doubling time? The present amount is divided by the annual release, giving us approximately 86 years. Yes, you heard it right. It would take nearly 86 years to double the atmospheric carbon dioxide if the emission rate remains constant. But here's the kicker. Constant emission rates aren't sustainable. It's a stark reminder of the urgent need for change in our carbon footprint. If you found this information eye-opening, remember to give this video a thumbs up, and if you want more mind-blowing content, hit that subscribe button. Thanks for joining us today on TU. Until next time, stay informed, stay green, and care for our planet. See you in the next video.